Welcome to number 2 of the frequently asked questions to do with enthalpy of combustion. Here's another typical question that you might get in exams. And the key concept here is converting between kilojoules per gram and kilojoules per mole. So let's have a look. It says the table gives the heats of combustion in kilojoules per gram for a number of different fuels. Okay, and here's the question. A fuel was tested and it was calculated to have an enthalpy of combustion of 2016 kilojoules per mole, and you have to identify which fuel that is from the list given. So you have to convert between these two values, kilojoules per mole and kilojoules per gram. Okay, so how do you do that? Alright, let's have a look. So kilojoules per gram is what we've got, and we want to go to kilojoules per mole. So the whole idea here is, if you remember back when you first learned some chemistry and the concept of the mole, we said that 1 mole of a particular element was its relative atomic mass in grams. So if you had carbon's relative atomic mass is 12.01, and so if you wanted to go and measure out 1 mole, you had to go and actually measure out 12.01 grams. Okay? And so there's a connection there between grams and moles. So if we have 1 gram of a substance, in order to find 1 mole of that substance, we have to have its relative molecular mass, or in grams. So we have to times by its molecular mass. Right? So if we want to say for methanol, we want to find out how much that value was in moles, we need 1 mole of methanol, and so therefore we need its molecular mass in grams. So whatever value that is, we have to times it by its molecular mass to find out in moles. So here's the thing here. What we need to do is work out the molecular mass of all of these 3 things here. And so what we do is, we can quickly draw their structure or their formula and then calculate their molecular mass. So I'm going to draw their structure now. Okay, so there's our molecular formula for all of those. Now we work out the molecular mass of each of them, so same as you normally would, 12 plus 4 for the hydrogen and 16 for the oxygen. So I'm going to do that now and write their molecular mass down here, and then we'll check it out. Right? Alright, there's our molecular mass data. Okay, so methanol 16.032, ethanol 46.1, etc. So if this is the molecular mass, what we have to do now is get this value here, which is in per gram, right? And we times it by the molecular mass of each one to convert it to moles. So let's do the first one together, and then of course we'll speed up the rest. So in terms of kilojoules per mole, for methanol we need its value 22.7 times its molecular mass, which is 16.032. That means for methanol, and I might write it in a different colour for you. We might write it here so we don't get squashed. So when you times those 2 together, you get 363.9. I'm going to do the rest for you, and I'll meet you in a sec, and we'll look at the numbers and see what they mean. Okay, now I've done all the calculations and double checked everything. So what I did is we got the kilojoules per gram, times it by the molecular mass, right? Times it by the molecular mass to get kilojoules per mole. So let's write that up in there. Kilojoules. Oops, I've already done it. There you go, twice, 1 for each retina in each eyeball. Alright, so kilojoules per mole, and we've got to compare the values here. Now if we have a look at those values, we can see that this is the calculated version and this is the theoretical version, right? And so this value here is just slightly lower than this one here, and that's your answer. So this is the theoretical version, so the real version will be slightly lower than that. Okay, and so then the answer is, what is the fuel? Well, the fuel is propanol. And so that is the main thing that they're testing there. Can you convert kilojoules per gram to kilojoules per mole? Obviously, if you're timesing that way, then if you go the other way, you're dividing. Okay, and that comes up again in your normal enthalpy of combustion calculations as well, where you're doing it per gram and you can convert it to per mole. Alright, that was a quick and easy one. Frequent question 2. We're just doing one question in this video. See you in the next vid.